Hello and welcome to another one of these ADD videos. Today we're going to be looking at an example of confidence interval using Z-score. So again, quick recap. A confidence interval is two numbers in which we're using the sample mean to estimate what the population mean is. And we do that by using the sample mean plus or minus a margin of error. In this case, we're going to be looking in the scenario in which sigma is known. Alright, so again, the relationship between confidence level and significance level, alpha, is that 1 minus confidence level gives you alpha. Alright, so here is a nice little table. You might want to write this down. It will come in handy dandy. I can't believe I just said that, but it will come in handy whenever you're doing these. These are the major players for the confidence levels. And the problem we're going to look at here is our test score is normally distributed with the unknown mean for your stat class, and your study group of 9 people had an average of an 82 with a standard deviation of the sample of 6. You find out the standard or the variance of the population or your stat class is 25. What is 90% confidence interval? Well, what you got to do there is you got to first write the formula. So let's use red here. X bar plus or minus z of alpha over 2 sigma divided by the square root of n. So we know that x bar was an 82 plus or minus z alpha over 2. Well, in this case, if we have a confidence interval of 90, a confidence level of 90, sorry. Our alpha is 10, alpha over 2 is 5, and our z-score that corresponds to that is 1.64. Okay, just so you know where that came from, I'll be nice and I will go to the, oops, wrong page, z-score formula. And if you look up 0.950, it gives you 1.64. If you were to look at that number right there. Okay, so, well, all kinds of wrong stuff here. I should have pressed that button right there. Sorry about that. So we have 1.64 here. Oh, still yellow. It is 3 o'clock in the morning. I apologize for the technical difficulties. These are still rough draft videos, so bear with me. Now the question is, do we use 6? No, because that's not the population. We need the population there. And if the variance is 25, sigma squared is 25, then sigma is 5. So we have 5 divided by the square root of n. N was 9 people. So we're going to have 1.64 times 5 divided by 3. And we reach for the calculator. 1.64 times 5, enter, divided by 3, enter. 2.733. So what we can do is we can have two numbers. We're going to have 82 minus 2.73 for the bottom end, comma, and then we're going to have 82 plus 2.73 the top end. We're almost done. So if we do 82 minus 2.73, you're going to get 79.27. And then 84.73. So what you can say is that your mu lies between these two numbers, with what was it, 90% confidence. Okay. Now, the question is, would you expect these confidence intervals to increase as we became more stringent or more strict, or would you expect them to decrease? Well, let's think about it. Logically, if I make the distance between these two numbers greater, would you expect it more likely to, how's that mean? Yes. If I narrow this and say it has to be between 83 and 84, odds are that it's not gonna be in between those two numbers, and our confidence is really low. But if I say it's between 60 and 98, the likelihood of me getting that right is a lot greater. So what I tried to dictate there, if you increase the confidence level, you're going to increase the interval. In other words, the difference between these two numbers will be greater. Alright? You can also use these confidence levels to determine which ones are greater, or which levels are greater, population means are greater. Do some statistical inference as well, as opposed to just determining where the mean lies. Alright? Hope this has cleared up any confusion that you have over confidence intervals. Again, if sigma is unknown, you would use a t-score. Just practice a few of these. They're not too bad. And thank you, and have a nice day.